You have maybe done 3 trials with different masses, and hence you have different volumes. You've recorded the masses with units within parentheses, and you've recorded the volumes with units within parentheses. Now you can make a graph which has a proper title and labeled axes by having that there, and then you can highlight those columns. Then click Insert, Chart, and then you can make many different types of graphs, but today we're going to make a XY scatter plot. So you can see it's already got a title. It's got the y-axis versus the x-axis, and it's got the axes labeled with units as well. And we've got these data points. We can see kind of a general trend that as we increase the mass, we also increase the volume of that substance. And so we can now get our density from this graph by making a trend line of those data points and finding the equation for it, and hence its slope. So we can click Customize, then we can click Series, and then we can click Trend Line. So now we can see an actual line showing not necessarily the data points touching the line, but showing a general relationship between mass and volume. But this equation, this line can also have, click label, use equation. It also has an equation. Y is equal to mx plus b. Yeah, you may be familiar with that type of linear equation where m is the slope of the line. And in this case, the slope is rise over run, the mass of the pellets in grams, divided by run, the volume of the pellets in milliliters. So grams per milliliter. We can now see that our rise over run, our density, our slope, is 8.85 grams per milliliter, or grams per centimeter cubed. Now, we can also show R squared values and also error bars. Now, the R squared, it can never be above 1, but the closer it is to 1, the closer all of your data points are to the general trend line. So higher is better. And then we can have our error bars. We can show that our data points all were pretty consistent, but it might be reasonable and expected that some random data point which had this volume might have a mass within this range or so, within those bars. The larger your error bars, the larger your standard deviation, the more variability there is in your measurements. So smaller is better. And then, I can see that this is kind of a weird graph because, yeah, the mass starts at 0 here on the y-axis, but the volume does not start at 0 on the x-axis. And so I can double click here to adjust the horizontal axis and set a minimum value so we can see the graph starts now at 0, 0. So we can see, that we've got this general trend line showing that relationship, and we have also gotten our density from the slope.